All right, so it says a fishing boat leaves Tampa Bay at 4 a.m. and travels at 12 knots. At 5 a.m., a second boat leaves the same dock for the same destination and travels at 14 knots. How long will it take the second boat to catch up with the first one? All right. So for our chart here, we will have the first boat and we will have the second boat. Okay. We still have a rate, a time, and a distance. What type of problem is this? Are they going opposite directions towards each other or same direction? Same direction. They actually leave at the same spot and they catch up obviously at the same spot. So what do we know about their distances? They are the same, okay? So how fast is the first boat going? 12 knots, all right? How long did the first boat travel?
2 hours.
So the time here is T. What about the second guy? Do we know how long this guy traveled? So we know its rate. What is his rate? Second one.
14.
It is 14. Do we know his time? No. What do we know about his time? He left an hour later. So did he travel an hour longer or an hour less time? Less time. How do I say an hour less? T minus 1.
Why do you travel an hour less?
Just like on the bell work. You could have said T plus 1 and T. As long as the guy that's traveling longer and short, like as long as you have it set up correctly. So you could have said he left an hour earlier, so he traveled 1 hour longer. And you could have said this one is T plus 1 and this one is T. Okay? But pay attention, when it is same direction and the distances are the same, the guy that is traveling faster should be traveling less time, okay? Because it's the same distance, all right? So if this is T, this has to be T minus 1 because he's going faster. Make sense? Or vice versa. This has to be T and this has to be T plus 1 because he's going to be traveling longer because he's going slower. And how do we find... So, how do I find the distance? What is the distance?
The first one is
12t. All right. What about the second one?
14t. Well, it's over 15.
All right. What do we know about their distances? They're the same, so we have a very simple equation here. How do I solve it?
14t minus 14 equals 12t.
14t minus 14. Yes? All right. How do I solve this?
You subtract 14.
Variables on one side, numbers on the other, right? What's 12 minus 14? So what is t here?
Equals
T equals 7.
7.
And 7 hours equals the first boat. And then we just minus the 1, which equals 6 hours for the second
Right.
boat.
All right. They were specifically asking about the second. So if I set it up like this, then I have to say 6 hours would be my answer because he traveled 1 hour. But when you have mixture problems, it is, as it says, a combination of different substances. And so what will happen is they'll say it is this percent of this mixture and this is this percent of that mixture. And what we want is we want a total mixture at this percent. And so you have to kind of set these up a little bit differently. You actually have a little bit longer of a chart. All right, let's look at the first one, the first example here. A feed store owner wants to mix corn and barley to make 150 BUs of silage additive for cattle feed, okay? If the corn costs $3.80 per bundle and barley costs $2.60, how many bushels of each grain would he mix to yield an additive worth $3 a bushel, right? And so we have multiple things going on. First of all, we have two different types. We have corn and we have barley. And so that's the first part of this chart that we're going to set up. We're going to set up corn and we are going to set up barley. All right. And then we are going to set up one for our final mix. Our final mix. All right. Now for this, we have a count column and we have like, in this case, a price column. We're going to do some with percentages as well. And so you have kind of an amount for each piece, and then you have an amount for the total. So we have the number of bushels for this particular one. And then we have the price per bushel. And then we have a total cost. All right. So do we know the number of bushels of corn? Do we know the number of bushels of corn? We do not. So we're just going to say X here. All right. Do we know how much the corn cost? Yes. How much does the corn cost? So if I have the number of bushels and the price per bushel, how would I find the total price? What would I do with those? You would multiply, right? If I take the number that I have times how much it costs per thing, I would multiply across. So what's the total cost of the corn? 380 times X, right? You could just say 3.8 because we don't have to worry about that 0. What about the barley? Do we know how much the barley costs? I mean, the barley, how much barley we have? We don't, right? But we do know something else. We know the total amount, right, that he wants. He wants in total 150 bushels of all of it, right? Does that make sense? At the very beginning, he says he wants to mix corn and barley to make 150 bushels of additive. So we can jump down to this total mix here, right? And we know this is 150. Just like the time, think about how we did time. When it was total time, what did we do? If we had one of them, what did we do to find the other? When we had total time? Yeah, we subtracted. When it was total 6 hours and we had one of them as T, we said 6 minus T for the other. The total is 150 bushels. We know one of them is X. How do we solve for the other one? Subtract. So we're going to say for barley, we have 150 minus X. Does that make sense? If we take 150 and we subtract how much corn, then we should have how much barley is left, right? Because he wants 150 in total. We also know the cost of the barley. What is the cost of the barley? Yeah, it is $2.60. So then what is the total cost?
2.6 times.
And then make sure, what do we do here? Parentheses, right? Always do parentheses there. Okay? Always do parentheses here. So his mixture is going to be 150 in total, right? And the cost is going to be how much per bushel? $3. He told us that's what he wants to do. $3. So what is going to be the total cost of his mixture? Just multiply like we did everything else. This has all been multiplied. So 150 times 3. What is 150 times 3? 450. Right? Does everybody see how we filled out the chart? All right. Now let's talk about how we solve this. I should be able to add the cost of my corn to the cost of my barley and get the total cost. All right, so we are going to set them equal. We're going to add them up and set them equal to 450. So we're going to say 3.8x plus 2.6, 150 minus x equals 450. All right, and so now we're going to distribute and solve, right? Distribute and solve. So we're going to say 2.6, distribute that through. So 2.6 times 150 gives you what? 3,900. Oh, they just took them out. Okay. They took out their decimals. That's fine. 2.6x equals 450. Yeah, if you want to get rid of your decimals, you can. It doesn't matter either way. But remember the shortcut, you could bump all them over. That's what the book did, so just pay attention when you see it bigger. All right, so 3.8 and negative 2.6 are like terms. So I'm going to combine those. What is 3.8 minus 2.6? Hopefully 1.2. Yes. Plus 390 equals 450. How do I solve?
Subtract 390.
Subtract 390, right? So I get 1.2
You get 40.
x equals 60.
Oh yeah, it is.
Yes. And then divide by 1.2. 60 divided by 1.2 is 50 bushels. Well, all right, 50 bushels. What did they ask? Did they ask for just one of them? No, they want how many of each type. Which one did we solve for? Which one is 50? The corn. So this is 50 bushels, right? We know the total is 150. So what do we do with that 50 to find the barley?
It would be 100 track.
Yeah, 150 minus the 50. It should be 100 bushels of this guy. And that is our answer. So very, very similar to the price, but they're going to replace price with percentage. Nickel silver, often used for coating tableware, is an alloy containing 15% nickel, along with copper and zinc. How much pure nickel must be melted with 70 pounds of nickel silver to make an alloy that is 20% nickel? Okay? So in this case, they have given us some percentage situations here. And they're saying, okay, I have this combination, alloy is a combination of different metals, and I want to mix it with something else that has a different percentage and come up with a new one. All right? So they've given us two things here. They have given us nickel silver here, and then they've given us pure nickel. All right? And so those are our two types, just like the Chinese and the Indian tea were our other two types. So we're going to set up a chart for my nickel, silver, and then my pure nickel. All right. And then our final thing that we're going to calculate here is the alloy. All right. That's the alloy. Let's scoot all this up because I already know I'm going to need more room. All right. Now, just like before, we have pounds. So we have an amount, right? Because that's what they've given us, pounds. Then they have given us this percent of nickel. How much nickel is in it? Percent of nickel. And then pounds of nickel, because it says we're calculating how much nickel's in it. So this is going to be how much of the type that you have. All right, pounds of nickel specifically. So in the first part it says, how much percent of that nickel silver is actually nickel? What percent of the nickel silver is actually nickel? So of the nickel silver, what percent do I have? In my problem, what does it tell me? The nickel silver is how much actual silver? What percent is actual silver in it? What's it tell me? 15%. All right, if it says pure silver, how much silver do you think is in pure silver? 100%, right? And so this pure silver, or nickel. Pure nickel is going to be 100% nickel. Does that make sense? I mean, if it's pure of a substance, it should be 100%. All right? For my alloy, how much percent nickel do they want the alloy to be? What do they want to come up with at the very end? What percent? 20%, right? So far, so good? All right. So we know our percentages. That's pretty straightforward from the problem. We know our percentages. Now let's go to the amounts. It tells us how much of the pure nickel must be melted with 70 pounds of nickel silver. So what did they just give us in this chart? What did they give us? The pounds of nickel silver. They gave us 70 pounds of nickel silver there, right? So far, so good. So if we look here, it says how much pure nickel. So that automatically tells us we don't know how much pure nickel. So what do we put there if we don't know? X, all right? Now, if we know we're going to start with 70 pounds of the nickel silver, we're going to add X amount of pure nickel. What is our alloy going to be? How many pounds is that going to be? 70 plus what? What we added, right? So this is going to be 70 plus X. Everybody agree with that? Okay? So just like all the other problems, how do you think I'm going to calculate that last column there? I'm going to multiply, right? If I take 70 pounds of nickel silver and it is 15% nickel, how many pounds of nickel will I have? Well, I need to multiply 70 by 0.15. Does that make sense? So I'm going to go across there and I'm going to say, well, this is going to be 70 times 0.15, which is going to give me what? 10.5. All right, 10.5. What about the pure nickel? How am I going to calculate that? I need to change it to a decimal, right?
Would it just be X?
Yeah, just 100% is just 1, right? So this is just 1 times x. This guy is just x, right? And then what about the last one? 20%, that becomes what? A decimal. What decimal is 20%? So 0.2 or 20, but you can just say 0.2 times what? 70 plus x. Okay? You're just multiplying across. So if I take the pounds of nickel from the nickel silver and I add it to the pounds of pure nickel, I should get the pounds of nickel in my mix, right? So these two should add up to this guy, all right? Those two should add up to that one. So I'm going to say 10.5 plus x should equal 0.2, 70 plus x. And then I just need to solve. How do I solve it? I'm going to distribute, right? So we're going to say this through 10.5 plus x. What's 0.2 times 70? 14? Yes? Plus 0.2x, right? And then what else do I do here? What do I need to do? Yeah, variables on one side, numbers on the other. And it doesn't really matter which way you add. I'm actually going to move my variables over here. Okay. That's going to cancel. What's 1 minus 0.2? 0.8, right? And then I'm going to move my numbers to the other side. What's 14 minus 10.5? 3.5. All right. So now what's my final step here to solve for x? Divide by 0.8, right? What's 3.5 divided by 0.8? 3.5 divided by 0.8. It's going to go to 3 decimal places. 4.375. What did I solve for? Which one did I solve for? Pure nickel. Is that what I was trying to solve for? Go back to your problem. What did it ask? How much pure nickel, right? And did I solve for it? Yes. So you'd say pounds of pure nickel right there. That is your answer. You need to describe it for me. I need to have units. I need to have what it is. So you need to tell me pure nickel there. I'm not going to assume that you knew you solved for pure nickel. You're going to have to tell me that, okay? So they said, how many gallons of pure alcohol must you add to 25 gallons of 28% alcohol solution to obtain a solution that is 40% alcohol? So at the very beginning, they have told us that we have two different substances here. We have pure alcohol, and then we have an alcohol solution, okay? Pure alcohol and an alcohol solution, all right? So very often in chemistry, different reactions will react differently depending on what percentage of alcohol it is, like how quickly it'll burn or whatever, okay? And so they have had pure alcohol and an alcohol solution, and they want to mix those two to come up with a new solution, okay? So I have pure alcohol, alcohol solution, and then my final is going to be the mix of those. All right? I'm going to start with percentages when I fill this out because they have given me some percentages here. Pure alcohol. How much alcohol is pure alcohol? Well, it's 100%, right? The solution. What's the percentage of my solution? 28%. My final mix. What's that solution going to be? That's going to be 40%, right? 40%. So that column was very simple to fill out. My percentages, they just boom, 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 they gave them to me, okay? Do I know how much pure alcohol? Well, no, it actually says how many gallons of pure alcohol. That quite literally tells me where I'm going to put my variable. How many is a key indicator that that's probably where you're going to have a variable, okay? Must you add to 25 gallons of alcohol solution? 25 gallons, right? And then my total solution is going to be however much alcohol I add plus how much I had already should equal my total. So X plus 25 is going to be what my mix is, or 25 plus X. It doesn't matter what order you add. So once I have these two columns filled out, this guy's really easy, right? All I do is multiply across. Anything times 100% is just itself because 100% is 1. 25 times 28%, you should have gotten 7 there. So 25 times 0.28 is 7. Then I have 25 plus X times the 40%. So 0.4, always change these to decimals, times that group. And then these two added together should equal this one. So X plus 7 or 7 plus X equals 0.4 times this. And now I'm just solving. Distribute. So leave this guy alone. 0.4 times 25 is 10. 0.4 times X. I moved my 0.4 over here. 1 minus 0.4 is 0.6. I moved my 7 over here. 10 minus 7 is 3. And then 3 divided by my 0.6, you should have gotten 5. 5 gallons there. Did I solve for what they asked for? How many gallons of pure alcohol? My X was my gallons of alcohol. So yes, I'm done. I'm done with that question. If they had gone on and asked me more questions like, how many gallons of the mix will you have? Well, you would say 25 plus 5, I would have 30 gallons of the mix, right? If they had said, how much alcohol do you have in your mix? Well, you would have plugged in the 5 over here and figured out how much alcohol you had in the mix. So you have to pay attention to what is it asked me. And did I answer the question, right? Did I answer it correctly? Did I answer all of their questions? All right. So I want to show you one more type of problem, and then I'll give you your homework. All right. So really quickly before we do that last type of problem, in your book, they have kind of the step-by-step, what do you do to do these? Read the problem carefully to find the unknown quantities, translate it into algebraic expressions. All right. So before you do anything, read the entire problem, okay? It may seem overwhelming, but read the whole problem first. And then you're going to make a table. When you make a table, you are looking for 2 specific things here. You're looking for butterscotch and cinnamon, right? You're looking for, pure alcohol and alcohol mixture, okay? So you're looking for 2 things, Chinese tea, Indian tea, that they have given you, that you're going to mix together, okay? And so those are going to be your first 2 parts of your chart, the 2 things they have given you. And then you're going to say, what are they talking about? Are they talking about gallons or just price per pound? Or are they talking about a unit or something? And that's typically going to be your first column. My gallons, my pounds, my units that they have given me. Your second column is typically going to be the amount per. So dollars per pound, percentage per those gallons that you have, okay? So your next column is going to be the amount per. Dollars, units, whatever units is per. In this case, percentage sometimes. And then your final column is going to be what happens when I multiply them. How much alcohol do I have in that? How much dollars did I spend on that? Okay? My third row is always going to be a culmination of the others. So if they tell me I want 50 gallons of my mixture, or if I want 20 pounds of my candy total, then that's what it's going to be. Or if they say, what is the total? Well, then you're going to add those two up to get that bottom row. Your second column is not going to add up. Okay, so hear me out. Your dollars are not going to add up to your total dollars. Your percentages are not going to add up to your total percentages. That one's going to be different. They're either going to hand you that percentage in the equation, or that's going to be what you're going to end up solving for. Okay? But that third row, third column will always multiply across again. Okay? So that's your goal, is to set this table up. Once you set the table up, you pretty much have it. Your 2 on the right is going to equal your bottom. Okay? And so then you add those 2 up to equal the total column one, and then you're just using algebra to solve. You're distributing, you're combining like terms. You're going to move your variables to one side, numbers to the other, and then your final step will be to divide. Once you solve for your variable, make sure that you have answered the question, okay? Because sometimes you will have answered the question. Sometimes you'll have to use that answer to actually go back and answer the question they wanted, okay? And so you have to make sure that you have answered which part of your column they were asking for, all right? So let's look at one other type here. This last type has multiple mixtures in it. Kim sells pistachios containing 80% pistachio nuts and pistachio surprise containing 30% pistachio nuts. So she has 2 different mixtures of nuts. One is 80% pistachios, one is 30% pistachios. How much of each could she mix to make 12 pounds of a new mixture that is 40% pistachios? Okay, so we have this mix 1 here, and we have this mix 2. And I don't want to write pistachio that many times. So I'm going to say mix 1, right, mix 2, and then final. Let's go a little faster. All right. So we are doing it in pounds, right? And so my first part's going to be pounds. Then I'm going to say, well, percent of pistachios, right? And then how many? So pounds of pistachios here. So my first mix, do I know how many pounds? I don't. I do know my percentage though. So I'm going to write 80% here. All right. My second one, I know my percentage, right? 30%. And my final, do I know that percentage? Yes. What is that percentage? 40%. All right. So like he said, we know pounds of the final, 12 pounds of the new mix. That's going to be 12. So what do you think I'm going to do for the other 2? I don't know either. Yeah, I'm going to use a variable. So if I put a variable here, then how do I know what mix 2 is going to be? 12 minus x, right? Makes sense? So this gave me multiple percentages and mixtures. And I'm still going to go back and add. So this one does not have a pure. All right, you notice there's no pure like our example did. So sometimes they'll use the word pure, but sometimes they'll give you all of the percentages right away. All right, does that make sense? So in the first example that we did, they said pure alcohol. In this one, they said, here's the percentage, here's the percentage, here's the percentage. Okay, and so you're going to work it just the same as the other one, and you're going to multiply over. And then once again, when you multiply over and add down, you will have your equation. All right, so I want you to see that there's going to be, on your homework, you're going to have multiple different crossed. All right, so for my mix 1, what is my pounds of pistachios going to be? How do I calculate that? Multiply, so 0.8x. What about my mix 2? Point 3, always group it when you have groups, all right? And what about my last one? What do I do there? Multiply. What is 0.4 times 12? Yeah, so just 4 times 12, and then add your decimal there, 4.8. And then again, add these up, 0.8x equals 0.3, 12 minus x, which equals 4.8. That's a plus. I keep writing an equals. All right, so again, I'm going to distribute, combine like terms, and solve. All right? And I don't think this is the issue here. I think this is going to be your hardest part of all of these, is setting this chart up. All right? Setting that chart up.